Today's topic is signal integrity. What is signal integrity? Signal integrity is the study of all the problems that arise in high-speed products due to the interconnects. Or it is all about how the electrical properties of the interconnects interacting with the digital signals voltage and current waveforms and how they can affect performance. It means signal integrity is the area where we study high-speed design problems. In the high speed, whenever we go for higher frequencies, then we face so many problems with respect to this signal integrity. Like here we study the behavior of interconnects, electrical properties, and how they are interacting with the voltage and current waveforms, and entirely the process, what kind of problems that we face, and how the signal integrity will affect the performance, high speed design performance. Everything collectively forms the study area of the signal integrity. So when we talk about the signal integrity, the main problem in this area is crosstalk. Crosstalk is the problem of having energy coupled between traces or from one trace to another adjacent trace. For example, consider here this is the transmission section and here receiver section, and these two are connected with the help of two traces. So these are the transmission lines where we can transmit the signals from transmitter side to the receiver side. These traces, imagine these traces are laid or routed in printed circuit board side by side like parallel traces. So what is crosstalk? The crosstalk is the signal or the trace one carrying signal. Though it is carrying the perfect signal, the effect of this voltage or current signal is affected or is impacting the signal passing through this another trace, adjacent trace. So this interaction of one trace with another will cause signal distortion in the trace 2. So this will cause a noise in the trace, adjacent trace. So what is crosstalk? Crosstalk is a coupling of energy between the conductors. Or we can say that this crosstalk is usually caused by mutual capacitance or mutual inductance. And the level of crosstalk is very high when we choose faster rise time signals or high frequency signals. Voltage or current of one trace interacting with or pass over to an adjacent trace creating unwanted noise is crosstalk. So one important step to minimize the crosstalk is to maintain the enough gap, sufficient gap between the two tracks or two traces or two transmission lines. In case of microstrip or strip line transmission lines and printed circuit boards, keep the spacing. Suppose this is a trace 1 and this is trace 2, which is of width W, and this is reference plane. In order to reduce the crosstalk, we need to maintain enough gap, that is, what is the minimum gap to be maintained is 2W, 2 times the width of the single trace. So in the case of strip line, we have to leave this much gap in order to reduce the crosstalk. This is one of the guideline given by Eric Bogatin in his book Signal Integrity and Power Integrity Simplified. So one more step to reduce the crosstalk is minimizing the parallel run length. So as we have seen, the two side by side tracks not having enough gap where we are allowing one trace to interact with another trace, and at the end this is leading to the crosstalk problem. So to avoid this one, avoid routing the traces parallelly. And one more guideline to reduce the crosstalk is placing the conductor close to the ground plane. The ground plane concept or a reference plane concept we are going to discuss in our next video. So this reference plane, which is providing a return path for the return current for these two traces or the transmission lines, should be placed closer to these traces. It means the dielectric substrate height should be reduced in order to reduce the crosstalk. These three tips or three guidelines have to be minimized. Being high-speed design engineers, we need to keep this in mind to reduce the crosstalk. We need to keep enough gap or enough separation between the two traces, that is 2 times the width of the trace, and minimize the parallel run lengths, and placing the conductor close to the ground plane by reducing the dielectric substrate. These three guidelines will help you to design good high speed product. So the reference for this crosstalk topic and the signal integrity is book written by Eric Bogatin, Signal and Power Integrity, Simplified 2nd edition. He explains 100 different or generalized guidelines for the high-speed design in order to avoid the signal and power integrity. So we discussed 3 among them. In the next video, we'll continue with other related topics. Thank you.